morning, good afternoon, or good evening. We are Group 4 from BCS 1A. We will reporting vectors and scalar. First, what are the topics you may know in this video? First, what is vector quantity? Second, what is a scalar quantity? Third, the scalar and vector difference from each other. And last, how to solve vector problems.
Hi, I am Aidan Jeho M. Montoya from BSCE 1A. I am here to report about scalars and vectors. What is vector? In physics, a quantity that has both magnitude and direction. Example of vector quantities: displacement, velocity, and acceleration. What is scalar? A physical quantity that is completely described by its magnitude. Example of scalar quantities: volume, speed, energy, time, mass, and density.
My name is JBC Miranda from BSCE 1A. I am here to report the difference between scalars and vectors and the parallelogram law.
What's the difference between vectors and scalars? Vectors, a quantity that has magnitude and acts in a particular direction, is described as a vector. Vector possesses both magnitude and direction. Scalars, a quantity that has magnitude but no particular direction, is described as scalar.
Good morning, guys. I am Uriel B. Romero from BCE 1A, and I am reporting the analysis vector. Analysis of vector. There are three methods: the analytical method, additional complex number, and parallelogram law. Our first method is analytical method. Here we have example problem. The given are F is equal to 200 Newton, 35 degrees, T is equal to 300 Newton, 50 degrees, and J is equal to 100 Newton, 30 degrees. The things that we need to solve here is vertical and horizontal vector, resultant forces, summation of x and summation of y. Then we proceed in problem solving. Here, fx is equal to f cosine theta equal to 200 Newton multiply cosine of 35 degrees is equal to 168.83 Newton. Is fy, when it is f sine of 35 degrees is equal to 114.72 Newton. The next is Tx is equal to T cosine theta is equal to 300 Newton multiply cosine of 50 degrees. The answer is negative 92.84 Newton, and it was negative because the x is in the left corner. When it is in the right corner, it will be positive. T sine theta or 300 Newton multiply sin of 50 degrees is equal to 229.81 Newton and positive because it is upward in y. And the last is Jx is equal to f cosine of theta equal to 100 Newton multiply cosine 30 degrees equal to negative 86.60 Newton, and it was negative because it was in the left side of x. jy is equal to f cosine theta is equal to 100 Newton multiply sin of 30 degrees is equal to jy equal negative 50 Newton and negative because the y is in the downward side. Now we will find the summation of x is equal to 168.83 Newton minus 192.84 Newton minus 86.60 Newton is equal to negative 110.61 Newton. We will move in the summation of Fy is equal to 114.72 Newton plus 229.81 Newton minus 50 Newton is equal to 294.53 Newton. Now we get the summation of x and the summation of y. We will get the resultant force or R is equal to the square root of the summation of fx squared plus the summation of fy squared, and we substitute the summation of fx is negative 110.61 and the summation of y is 294.53 and we squared it and add and it will be 314.61 Newton and it will be in the quadrant 2. We will get the tangent A. The formula of this is fx squared divided by fy squared that we will get 8.03 degrees. Now we complete the missing variable and our resultant force is in the quadrant 2 and our degrees is 8 degrees and our summation of y is 294.53 Newton and our summation of x is negative 10.62. The second is additional complex number. First is polar form. This will be x equal r multiply cosine theta, y is equal to r multiply sin theta, and r is equal to the square root of x squared plus y squared, then z is equal to r multiply cosine theta plus I sin theta. The polar form is the form that we use in analytical method. The next form is rectangular form. It's from the root word rectangular. It was used in rectangular shape. If you were to represent a complex number of according to its Cartesian coordinates, here we will use the Cartesian coordinates. And the last form is additional complex number, the trigonometric form. The trigonometric form of complex number contains the distance of complex numbers coordinate from the origin and angle formed by real axis and segment connecting the complex number and the origin. And we will use here is sine theta, cosine theta, tangent theta, cosecant theta, cotangent theta, and secant theta.
Parallelogram law. Let's move on to law of sine. A over sine A is equal to B over sine B is equal to C over sine C. Then, law of cosine. C squared is equal to A squared plus B squared minus 2AB cosine C. B squared is equals to C squared plus A squared minus 2ab cosine b. A squared is equal to b squared plus c squared minus 2ab cosine a.
That's all for today's lesson. Hope you all learned about the topic. See you again in our next video. Bye.